Let's look at all of the records of the employee table. Here it looks like we have 12 employees. In other words, we have 12 records. How many fields do we have? It looks like we have 7 fields. As expected, our employees have a whole bunch of different last names. The first employee's last name is Adams. The next employee's last name is Brown. Let's take a really common last name. How many employees have the last name that is equal to Smith? Well, let's look for that by adding a where clause. Where, last name, equals, and then type single quote, SMITH, single quote, and then run the query. Notice we get just one record, Sally Smith. How many employees have the last name of Brown? Inside our single quotes, we'll put BROWN and hit the execute or the F5 key. And again, we get just one employee. Now here we've written out both queries at the same time. What happens if I hit the execute button when both queries are up? You get 2 result sets. The first result set is the first query, looking for all Smiths, and the second result set is the second query, looking for all Browns. If we wanted to keep all of this code in front of us but just run the Smith query, what you can do is select just the query you want to run. And this gives me the Smith query. Select this code, and we get the Brown query. Now, if we don't select anything, then all of the code in your query window executes. Go ahead and delete all of your code, and let's try a new example. Let's take another look at our entire employee table. Type Select All Fields from Employee and hit the Execute button to run the query. Since I don't have a where clause, I'm going to get all of the records in the table. Now we can query off of the last name, looking for Smith and Brown. We can also query for first name. A common first name is David. Let's look for all the Davids. Type where first name equals single quote DAVID single quote and execute. Looks like we get 2, David Kenson and David Lawning. How about we change the first name criteria to Lisa? Looks like we have only one Lisa. Now let's say your goal was to look for all the employees named Lisa or David. In other words, we're going to find 3 records in our result set if we do this. We can put the word or, first name equals David. Execute the query, and we'll find all the Lisas or the Davids. And you get a total of 3 records in your result set. Now, the reason you can't put Lisa and David in the same line with an equal sign is because an equal sign looks for one exact match, and not an enumeration or many exact matches. If you wanted to make this query easier to read, there's another operator besides the equal sign that looks for exact matches. Type the word in, followed by a set of parentheses, and separate each exact match with a comma. Execute this query, and you get all the Lisas and Davids. You can keep going. You can find all the Lisas, Davids, and Erics. Single quote, ERIC, single quote. And now we get 4 records in our result set. Here's another example of a very precise piece of criteria that comes after your where clause. If you select all employees where the first name is Barry, you get 1 record. Now, there's more than one employee whose first name starts with the letter B. Erasing every letter after B gives us no records, because the equal sign is looking for an exact match. In other words, everybody whose name is B. However, if you change the equal sign to a less precise operator called like, and then say B, it still doesn't work until you put in what is known as a wildcard. The percent sign can mean any number of letters and any type of letters. Let's execute. And notice you get Barbara and Barry. If you understand that the percent sign is a flexible way to find any number of characters and any type of characters to look for patterns, but you're wondering what is meant by an equal sign is a precise operator and the like is an approximate operator? Look at this query. We're going to start off with first name equals single quote B % single quote and run it. And you'd expect to see Barry and Barbara, but you get nobody because the equal sign is looking for a name exactly B %, and nobody has that name. By changing the equal sign to the like operator, we get the results we saw from a few moments ago. The wildcard trick can be used with other letters too. Let's look at all of our employees first. We have 12 employees. Now we have some employees who have the first name starting with the letter E, and we could easily look through and see who they are, but let's let SQL Server tell us. Put where, first name, like, single quote, E %, single quote, and execute the query. And you see one record in your result set. Now we don't have to just look for patterns that start with a letter. We can choose to find everybody ending with a letter. For example, how many employees end with the letter Y? In this case, we'll put the wildcard first because we're looking for any letters that finally conclude with the letter Y. Execute the query and you get Barry, Terry, and Sally. Other names that could appear if they were in your database could be Joy, Andy, and Lindsay. Let's take it a step further. Instead of starting with a specific letter or ending with a specific letter, let's look for patterns or letters anywhere in their name. For example, how many employees have a double R anywhere in their name? All you would do is single quote, %, double R, %, single quote, and execute the query. You get Barry and Terry. Now this next one is a borderline trick question. Let's say you were looking for people who have an A in their name. Single quote, %, A, single quote. Now here's the question. We have somebody named Alex who starts with the letter A. We have somebody named David who has an A in the middle of his name. And we have somebody named Lisa who ends with the letter A. Will David be the only one to appear because he's the only one with an A in the middle of his name? Or will Alex appear because there's an A in his name? Will Lisa appear because her name ends with the letter A? Well, what does the % wildcard mean? It means 0 or any number and any type of characters. So make a prediction. Run your query. Notice we get Alex. Why do we get Alex? Because this % sign represented 0 characters before it found an A. For Barry, well, it represented 1, and then it found an A. Lisa, it found an A, and then no characters after it. The % sign represents 0, 1, or as many characters as it needs to find the pattern. Now this might sound like a word riddle, but what if you wanted to find everybody who has the letter A somewhere after the first letter? In other words, no Alex, because he has an A as the first letter, but no letter after the first letter is an A. David, second letter is an A. Yep, his record should show up. Lisa, the last letter is an A. Yes, her record should show up too. So we want to force it to find any letter for the first letter and then an A anywhere after it. So what we're going to do is use the underscore. The underscore wildcard is similar to the %. It looks for any letter, but it's exactly 1 character long. Now that we've ensured there's at least 1 letter, we want to look for an A anywhere after the first letter. So we'll type underscore %A % and execute the query. Notice we don't see Alex, but we see Barry, who has an A as the second letter, Lisa, the fourth letter, David, Barbara, Sally, and so forth. You can use wildcards, and you can use many wildcards together. For example, we learned that A % finds all of the last names, like Adams, that start with the letter A. If we wanted to find all of the names that start from A to B, we can add to our criteria, or last name like B% in single quotes. And run it. You'll notice the result set. We have all last names where the first letter ranges from A to B. How about A through K? Well, we can continue this pattern, run this query, and you will notice you get a range of last names from A through K. There's an easier way to do the same thing, and I can do it with one criterion. Let's get rid of all this other stuff, and let's realize that what we want is a bunch of choices for the first letter, A, B, C, D, E, F, G, H, I, J, K. So let me put a square bracket around the A. Now, if I just list A and B in the square bracket, then those are the two choices I will allow for the position of that letter. So an A or a B will suffice. How about A, B, C, D, E, F, G, H, I, J, K? If I list all those, it gives me A through K in the result set. Now, what if I want a series of letters, A through K? What if I just listed A and K? Well, notice I've lost ground, because this just says A or K and nothing in between. Now, if A is the first of my choices, and K is the last of my choices, and I want all the letters between them, I can put a hyphen between them. Now we'll find all the letters from A to K. Okay, here's one more important trick with wildcards. Let's start off with something simple by looking at all of the employees. Okay, we get 12 records, and you probably remember that we have 3 employees who have an O as the first letter of their last name. Let's again find them. Where, last name, like, and between the single quotes, we'll do O%. There's our 3 employees. Now, we want to get rid of Osako. How are we going to do that? Well, one way is to say, I want the first letter to be an O, but I don't want the second letter to be an S. Here's what we can do. Put the caret inside of the square brackets, and that says the first letter should be an O, but in the square brackets, the second letter should not be an S. And we get just O'Hare and O'Neill. Now, we could have had a name like Olson, which isn't exactly an Irish name, so how am I going to get rid of all of the alphabetical characters for the second letter? Well, I'll just change the caret to looking to make sure that the second letter is not anywhere from A through Z. So if you like ranges, there's another type of range query we can do. This one will be querying the grant table. Notice that grants come in different amounts, from 4,700 to 41,000. If I'm looking for grants that are greater than 20,000, I can do this, where amount greater than 20,000. Run it, and you notice you get only the grants that are more than 20,000. What if you were looking for grants that were between 20 and 25,000? We can type and amount less than 25,000. Let's look for an expected result before we do this. It seems we have 1, 2, 3, 4 grants that are between 20 and 25,000. But only 3 show up in the result set. With 25,000, I use the less than symbol. If I want to change this so it's inclusive, we can put an equal sign here and an equal sign here, run it, and now you get all of the grants between 20 and 25,000. There's an easier way to do this. If you say amount and the word between 20 and 25,000 and run it, you get the same range. Using the between with the and is inclusive. What do I mean by inclusive? If you ask somebody to pick a number between 1 and 10 and they answered 1, would that be correct? Yes, 1 is considered to be between 1 and 10. In other words, 25,000 is considered between 20 and 25,000. While you're learning SQL Server and one of your friends or coworkers who is known for being good at SQL Server asks you, "So what have you learned so far?" See if they know this trick. Start off by doing something fairly simple. looking for all the last names start with the letter O by going single quote O %, single quote, and run the query. Now, why did they run this query? Perhaps they ran this query because they were looking for O'Malley, O'Shea, O'Shanahan. The intention of this query could have been looking for Irish names that start with the letter O, and then have an apostrophe as the second letter. Well, we did find two potential Irish names, O'Neill and O'Hare, but we also found Osako, which is not exactly an Irish name. So there's a pattern we're after. O with an apostrophe. Well, an apostrophe and a single quote are the same thing. So if I put a single quote here, this is looking for an exact O. And this thing off to the right, this % with a single quote by itself, looks like an error. SQL Server says, hey, I got my two single quotes with an O. I don't know what this thing is off to the right. So what can we do? The first apostrophe needs to be the first delimiter of our string. The last apostrophe needs to be the ending delimiter of our string. But that middle one should not be a delimiter at all. It should be a regular apostrophe. The way to do this trick is to put a second apostrophe after the first apostrophe to disable its special meaning. And now we get the O apostrophe names appearing. Lab 1.1, Skill Check 1. Write a query that displays a result set of all records from the current products table inside of the JProCode database, where the retail price is $200 or less. When you're done, your result should resemble the figure you see here. Skill Check 2. Find all the records from the current products table that have the word Canada in the product name. Show all fields from the current products table when you do this. When you're done, your results should resemble the figure you see here. Skill Check 3. Grant is a table in the JProCode database. Show all the grant records with amount values between $21,000 and $30,000. Show only the grant name and amount fields. When you're done, your screen should resemble the figure you see here.